Hello everyone. In this video, we will learn about applications of hashing in data structures. Hashing is not only a theory concept, but it is widely used in real-world systems. We will see how hashing is used in databases, compilers, password security, file systems, caching, cybersecurity, and blockchain. Let us start with hashing in databases. In database systems, hashing is used to quickly locate records using a key like roll number, employee ID, or account number. Instead of checking each record one by one, hashing helps us reach the required record directly. The working is very simple. First, the record key is given as input. This key is passed to a hash function. The hash function generates a hash address, also called a bucket. Data is stored and retrieved using this address. Because of this, searching is very fast. Let us take an example of a student database. Suppose roll number R is used as the key. The student record is stored at address H of R. When we search for the same roll number, we apply the hash function again and directly reach that record. So the average search time becomes 01. Hashing in databases has many advantages. It provides very fast record retrieval. It reduces disk access, which improves performance. It is very efficient for large databases with millions of records. There are two types of database hashing. Static hashing uses a fixed number of buckets. Dynamic hashing allows the table to grow or shrink based on data size. Examples of dynamic hashing are extendable hashing and linear hashing. Now let us understand hashing in symbol tables, which are used in compilers. A symbol table stores identifiers like variable names, constants, and function names. Hashing helps the compiler manage these identifiers efficiently. In compilers, the identifier name is passed through a hash function. The hash value gives the index in the symbol table. This helps in fast checking of variable declaration, scope resolution, and type checking. For example, when the compiler encounters a variable named total marks, it hashes the name and stores it in the symbol table. Later, whenever total marks is used, the compiler quickly checks whether it is already declared or not. This improves compilation speed. Because of hashing, symbol table operations like insertion, search, and deletion take 01 average time. That is why hashing is preferred in compilers. Next important application is password verification. Passwords are never stored in plain text. Instead, they are converted into hash values and stored. This improves security and protects user data. Password hashing uses special properties. It is a one-way function, meaning it cannot be reversed. It is deterministic, so same password gives same hash. It also gives uniform distribution to avoid patterns. For example, user enters password ABCD at 123. This password is hashed using an algorithm like SHA-256. Only the hash value is stored in the database, not the actual password. During login, the entered password is hashed again. This new hash is compared with the stored hash. If both hashes match, access is allowed. Otherwise, login fails. To improve security further, salting is used, which adds a random value before hashing. Peppering adds a secret server-side value. These techniques protect against attacks like rainbow tables. Some common hash algorithms are MD5, which is not secure now. SHA-1, which is deprecated. SHA-256, which is widely used and secure. BCRYPT and Argon2 are modern and highly secure password hashing algorithms. Hashing is also used in file indexing. It provides direct access to files stored on disk. Sequential searching of files is avoided, which saves time. For example, student roll number is given as input. Hash function gives the file address. The required record is accessed directly without searching the entire file. File indexing using hashing gives constant-time access. It uses memory efficiently. It is very suitable for large file systems. Hashing is widely used in caching systems. Caching stores frequently accessed data for faster access. Hash tables are ideal for implementing caches. Hash-based caching is used in database query caching, web browser cache, compilers for memoization, and even in AI and machine learning intermediate results. Caching reduces computation time. It improves overall system performance. That is why hashing is very important in modern systems. Hashing plays a major role in cybersecurity. It ensures data integrity, authentication, and tamper detection. If data is modified, the hash value changes immediately. Hashing is used in password protection, digital signatures, and secure communication like SSL and TLS. In digital signatures, the message is first hashed. The hash is encrypted using sender's private key. The receiver decrypts it using public key and verifies the hash. If hashes match, message is authentic. Now let us understand hashing in blockchain. Blockchain is a distributed ledger. Each block stores the hash of the previous block. This links all blocks together. Each block contains data, the hash of the previous block, and its own current hash. This structure ensures security. If any block data is changed, its hash also changes. This breaks the entire chain. So blockchain becomes tamper-proof and immutable. Blockchain uses strong hash algorithms like SHA-256 in Bitcoin, SHA-3, and ripened 160 for Ethereum addresses. Hashing in blockchain provides immutability, tamper detection, and a secure decentralized system.
Thank you for watching. Don't forget to share and subscribe. It really helps the channel grow and keeps you updated with new content. Your support means a lot. Thanks again.